This is going to be the same arm, but instead of supinated, it will be pronated, where the thumb has been carried over to the inside. All the same joints of ball and socket, hinge joint of the ulna, pivot joint of the radius, that is the bone that carried that thumb over to the inside. And then we will have a different position where we can see the saddle joint of the thumb coming toward us, ellipsoid joint from another angle for the wrist, and then the phalanges, which will all be pretty much the same as they were when we looked at them in the other position, except that there will be one difference, and that is that a hand is made to grip, which means that the arc of the thumb and the fingers will go around an axis somewhere in the middle there. I'm here with Stan Prokopenko, and I am going to analyze this picture of this arm and turn it into the simplest possible joints that I can do. And Stan's here with a large crowbar so that he can rap me over the knuckles hard if I make any mistakes, and I feel very, very eager to do this well.
Hello, everybody. I'm looking forward to whacking him with a crowbar.
Oh, this is going to be fun. Okay, the first thing is to get the whole thing laid out so that there's no surprises about proportion. When you get up close on something and you're putting detail in it, you lose context. So it is always wise to start with light lines.
And they're very light, so some of you guys might not be seeing anything right now if your monitors are very high contrast.
But very light is better than not so light, right?
Yes, for when you guys are drawing on your paper, very light is much better. For demos, I've learned that it's better to go darker just because people could see it. But this is a good example of how light you really should go when you are drawing on your own.
Oh, good. It's a good example. I'm so glad. I am so glad it's a good example. I have a habit of bearing down in the early parts of the drawing and bearing down so hard that it just destroys the quality of the drawing. And so this is my moment of truth. Doing this demo with an audience watching, if you ever want to bring down your confidence level a few stages because you feel like you're doing too well, do a live demo and watch it, especially with someone who knows drawing. See how it goes. It's a good experience. I'm speaking from my emotional condition of the last week.
All right, back to the drawing. So What is it that you're drawing here? You pretty much mapped in the basic shapes. Okay. I saw you doing some cross contours, and now we're going to a side note.
And that was all about proportions. So if we got the proportions good enough by comparing, now we are looking at how the plate joint of the, what have we got? The end of the clavicle and the acromion process. The acromioclavicular joint.
Yep, plane joint. So you got two flat sides.
And they changed position. They moved up, didn't they? No, in this one they didn't. So they're pretty much lined up.
Yeah, you're just moving them apart to show that they're two flat planes.
Yeah. And the point of this little aside demo is that boxes are a great way to understand plane joints. That one up at the top is almost a wedge as opposed to a box.
How so?
Because it's a little wider on the right. As it goes off to the right, it's a little wider. And
I see. That's because you use the curved line a little bit, huh?
Yeah. And I'm not being as meticulous as Scott Robertson would be, where he'd be doing this like an industrial drawing where he'd account for every point. This is simply to make the point that boxes are useful because they have corners, and so you know exactly how they're oriented. It's like having a compass built onto it. You know where the corner is. And once you've mastered those, you can put the plates in there. So that's what I'm going to do, is make this out of more than one box.
So you're basically doing the same thing now, but on your main drawing.
Yeah. I think it's a good idea to do those analyses on separate paper. It certainly helped me. This would be a more embarrassing demo. Finally some erasure.
It's like practice before you get onto the real thing.
It is.
But you didn't use a box for the chromium process.
No, I used a
What'd you do?
wedge.
Okay.
But figure, it's still got, a wedge has X lines, and then it's got spread out, however you put the letters on them. It's got spread out lines that are going away from us. So they can get wobbly, and that's why it is a good idea when you're studying perspective formally to turn them into boxes first and then spread them out to wedges. Now we're getting to the ball and socket joint, and this is a big deal. Let's put a little plane underneath the, trying to make that scapula look three-dimensional by putting in a couple cross contours just to show that the plane breaks, sort of making it a box.
You're giving it some thickness.
Yeah. And here we're looking at how to draw the most challenging thing, spheres. I'm putting two circles in there, more or less circles, and I put ellipses around them, and they look like they're in the same position. Does it bother you the way I draw with all of those?
Well, it would have been a little bit cleaner if you had constructed the spheres out of some straight lines instead of trying to draw a circle in one sweep and doing it 20 times.
It would be more accurate. And
Yep.
if it were a good day, I've had good days where I can put down an ellipse and make it just so right in one sweep, and you would admire me for it. It's just that this is one of those things where I'm trying to make sure, I got to make sure that's right, kind of hunting and scratching. Mm-hmm. But even though that ellipse on the left is off, for example, but it's close enough. These are close enough for doing what we're doing. We're trying to position a ball so that we know how a ball and socket joint works. And this is technical. I mean, it's like playing Bach. It's got to be precise enough to be clear. There's no chords where you can add in an extra note and not care about it. Here we're going to try to make it look right at us. This is a tough one where you're doing a foreshortened one kind of coming toward you.
Yeah, and even though the lines are wobbly, still your perspective is accurate and the point gets across, so it's okay.
And yeah, it's one of those things that if I was to take more time to make these really precise, which would be overkill for this project, that'd be nice. But when you know that it's off, you can say, all right, it's a little off, but I know where the equator line is. I know where the north to south pole line is that goes through the west. And then I know the one that goes 90 degrees to it. And so those three. I can even see that ellipse that I just put on there is a little too narrow, but it makes the point. The ball is on the other side, it's going away from us, and this one, I don't know what I'm going to do yet. Oh, that's the socket. Oh, here's the point to make here. Those ellipses on the ball, because the ball is convex, we'll just do the opposite kind of ellipses. Take whatever those ellipses were on the other side of that ball and then reverse them, and we'll have the right curves. So having done that, hey, look at that. Ooh, ooh.
Are you impressed by your line?
That practice is paying off.
Look at that. You're ghosting the lines in before you draw them.
It's about time.
It works. Okay, so now you're adding a box to the ball.
Yeah. That's to make sure that a cylinder can just be spinning around. As soon as you chisel an edge, you've kept it from spinning around. And putting that
That's the
socket
socket
joint, yeah. So now we'll do this humerus, and it will go from being a cylinder wedging into that block up there. So those cross contours show it's a cylinder. And now it's important to turn it into a box as it goes down here. And the reason it's important is because we've got epicondyles coming up. And those will make a hinge joint. And that set of epicondyles, if I ever get to them, come on.
Don't you wish you had a ruler?
Yeah, or a crowbar. Okay, now this is where having the elbow as a box form is useful, because the epicondyles come out of there like the hammer on a croquet mallet. So we have a depth line, a width line, and a height line, just like you do with a box. And in fact, to draw a confident cylinder, you necessarily relate it to a box. You have to run that minor axis off as if it were an axle. So I'm thinking that way. When I make those curves, even if they aren't landing perfectly, they are at least landing with an awareness of being arranged around an axle, which is the secret of drawing ellipses so they're placed correctly. And we're making that grip, even though that part doesn't grip over there like that on a humerus. I just did that so that the form would be clear.
Yeah, but I like how you did that. You started with just a box against a cylinder, and then you showed the cross contour line right on top of it, how it curves over, and then you just added that claw on top of that, curving around it. So I think if I were to do this, I would have started with the claw first, and that would have confused me. I think it's a lot easier to add the claw to the box.
Yeah. Yeah, and it's also kind of like figuring out puzzles. You know, you're figuring out, how can I best show this? Somebody did a humerus like it was an elephant or something, which was an elephant's trunk. Did you see that?
No.
It was a cartoon on the Facebook posts. But I didn't get it as form, though. When you do an elephant's trunk, you've got to turn it into forms that have a kind of boxiness to them, and that way you've really got control over it. Okay, so here we're just applying this, making that medial epicondyle stick out more and putting some cross contours so there's no question about how they're shaped. By the way, some of the examples on the Facebook posts I thought were remarkable.
Yeah, some of them are amazing.
They're professional level.
I was jealous of a few of them.
Yeah, there was at least one that was better than any of the ones that I've done. Okay, we're making the ulna something 3D. As soon as you put those rubber bands around there, it's just those cross contours are so amazing. That is part of the joy of drawing. Now, the next is the radius. So we're showing that the radius from the side would be a shape. But as soon as you pull that thing into space, pull one in closer to you, even if the proportions got a little thick, a shape turns into a form. And we know it's a form with a rubber band around it. And then that button on the end, which is just a portion of a cylinder. The theme of all of this is that to understand joints, you want to turn them into the simplest possible thing. And the simplest possible things you can control. So you can control a pivot that's drawn like mechanical engineers draw it. And that's what this is about. This is not to necessarily make your finished painting of a figure look all that much better. This is to understand what's going on under the surface. And of course, in the long run, it will make it so that you can invent better and change positions of things from what you see on a model. This is really sort of, if you're going to be a mechanic, it's like you're taking apart an engine to really understand all the parts. And now that radius will segue from being the round part that it is back there when it runs up against that lateral epicondyle. And there we go. As soon as we get that, wow, it starts to look 3D. That's great.
Yeah, I'm admiring the way you're constructing these forms.
Yeah. I did not learn this stuff until I was well into my 30s. I wished I had learned it when I was younger. I feel like it would have helped me to just do way better drawings. But the thing that made me so excited about it was watching Robert Beverly Hale and Drew Struzan and a few other people who just demonstrated that if you just get a few simple forms and put some rubber bands around them, they pop out of the paper like 3D. It was so mesmerizing. It was just so wonderful. I mean, that's a shape. We put two cross contours around it, and we make an egg for this ellipsoid joint that we're going to do at the wrist. And I'm finding where they intersect, the two rubber bands, where they intersect, so I could run that depth line, and that depth line now becomes what does it become? The axis of the radius.
Right. For the hand, right? You're talking about the wrist.
Yes, that's right. That's the end of the radius over there on the right, and that egg is the carpal mass.
Yeah. But it's not the only axis. I mean, it moves on.
It moves on more than one axis, but I was trying to do that so that it would line up with the end of the radius. I think you'll see better when I finish it further. I need to actually. There we go. Now we're gonna do the same thing we did with a ball and socket. Ellipsoid is a ball and socket joint, except it just doesn't have the freedom of movement like a ball and socket joint. So there we go. We're gonna do the same thing we did at the shoulder. We reverse those curves so that they are the receiving end of that convex egg. There is the concave section. Woo! And so it can move that way and that way. Those are two different kinds of axes. One is spinning on the x-axis, and one is spinning on the y-axis.
Oh, you're even trying to do a 3D arrow here.
I was going to try.
Oh, you got lazy on that second one.
Oh, wow. I could have done it. Okay. Let's see.
Now you're going to do it again
on
the main one.
Let's see if I'm hoping this will be impressive after all of that.
No, I remember this one was impressive.
Okay. It's my primary motive deep in my heart. Okay. That read to me.
Okay, back to the side note. What's this one doing?
This is going to show us that if the box of the body of the hand is in a position, that is not the same position as the base of the thumb, which will be the trapezium. Oh, wait. I'm wrong. First, we're going to show the fingers. I'm sorry. This was not in the order it should have been.
This is the ellipsoid joint of the fingers, right?
That's right, where the metacarpals meet the phalanges. And notice that I'm doing them as if they're mutually exclusive. That one can only move on the x-axis and the other one can only move on the y-axis. But I'm doing that to make a point. That ellipse that I'm just drawing there is an ellipse that you have to be aware of on an ellipsoid or ball and socket joint. And this ellipse, well, other one's like a tire gripping the ground. This one's more like a merry-go-round. That one spins on the y-axis. And so mastering both of those, that's y and z arc, and x and z arc and the y and z arc.
Mm-hmm.
And so the x and z, if you want to write this down, the x and z arc spin on y. And the y and z arc spin on x. That's a lot of information, and it's for a perspective class, not for this.
So you simplified them as one is going up and down, one is going left and right. Yeah. But really the joints have both movements available to them.
Yes, and watch what happens at the right, and you'll be so pleased how they come together.
So the left one is left and right, the middle one's up and down, and then that one's both together. There you go.
That was clever.
You're way too excited.
Okay. And now we need the receiving concave plane, which we can't show because we can't see it, but we can with those contours, and then little ghosting, just that other side will receive that plane. So that's what's happening at the fingers. Do I draw that next?
I hope so.
I hope so too.
Because we just told them how to draw the fingers, and then
maybe it got inserted at the wrong point. If it didn't,
no, yeah, you start drawing it right here.
Okay.
You're just working your way towards it.
Yeah.
There it is.
There we go. Now we're safe. No need to worry that we were going to truncate the train of thought. Okay, I see what I'm doing. I was trying to figure out what's that line. That line is the finger with its concave receiving end, the phalanx receiving that ellipsoid, that egg. this is way more fun to watch than it was to draw, as much as I love to draw. Because there's all that worry with, is it going to work? No, this works enough to make the point. Okay, now this one is what I was trying to explain earlier. This is the box of the hand is not necessarily the same box as the base of the thumb. Mm-hmm. So two sets of line systems that are mutually exclusive. If we're going to build a thumb out of that, we need that little line I took right out of the center there. That's a Z line. That's very important. When I do the saddle joint of that thumb, I'm keeping in mind that it's facing down and to the right. And the analysis I'm doing is not facing down and to the right as much as that box.
Yeah, this one you're just drawing a generic saddle joint.
Yeah.
With that, the S curve right in between the two. One is concave, one is convex.
Yeah.
Now right here, this is where you're going to start drawing it.
Closer
to what it actually is.
It still isn't there because this one isn't going to tilt down as much. I mean, look at that. It's if we were to swivel it so that that top part was to come down more lower, then it would be closer. But still, it makes the point. You can draw this in more than one position, and it's that box over there that makes the difference. Now, this will be the simplification of it. Those little outlines that I'm putting there, we now understand what the motivation behind them was. To show we have a concave convex that meets an opposite concave convex. So it's a saddle joint. Now we're getting to the hinge joints.
This is my favorite part of your demo.
Thank you. This big wheel that I'm doing is not a part of a finger. It's the arc of the whole thumb that grips around toward a center. And if we want to place those tumbling boxes of each phalanx or of a metacarpal, it helps to carve them out of a bigger form. That helps us keep track of it. And notice how it's helping me to know how to foreshorten those boxes. Each one of them is a segment. Connect them. And that ellipse, that opening of that ellipse at the center that it's going around, that's starting to fit the base of those phalanges in that metacarpal. I'm getting easier with my drawing by this time, too. I'm noticing that I could just fling it in there and not have to scratch around. Mm-hmm. It happens. There we are. We're putting now I notice that ellipse is not exactly on the same axis. There is a little, even though they are hinge joints, you can bend them a little bit. And I hope that was my motive for showing that, and not that I couldn't place the ellipse accurately.
Yeah, right.
Well, you gotta cling to something.
Oh, that one's a little bit off too.
Oh, well, okay. Maybe we should just comb through this with hey, we're going to clean it up afterwards. All sins will be forgiven. Okay, and then those width lines are really useful in drawing fingers and thumbs. Now let's do the fingers, because they're going to do the same thing except where there's more of a side view. That means we're going to see less of the tire tread of the wheel for these finger boxes than we did on the thumb, which where the tire tread was coming right toward us. And notice every width line, those X lines that there's an X line. And there's an X line. Those axle lines, those all go the same way. And that helps you, that you say, okay, I know that. The X lines all will go off to the left, and we've solved 1/3 of how to draw a box, and the other ones we'll figure out. But notice that those fingers are coming a little toward us. The other set is coming toward us less. It's almost a side view, so we're going to see less of the tire tread. Run all those X lines around there, and then give a nice thick side and a very foreshortened top. Mm-hmm. Thank you. This was your
yeah,
favorite?
I really like the way you've you simplified each section of the finger, each phalange. It's like the cylinder that you drew initially really helps to show how much each one curves around. And now the sides that point towards the middle of the cylinder, are those all pointing to the center axis, or
The sides that point to the middle cylinder.
to the middle of the cylinder, the center of the wheel?
You mean the sides of the boxes?
Yep.
Yeah, that we can't see in this case? Yes. You mean the lines that are pointing toward the center?
Yes.
Oh, that's kind of complicated. But let's say that the center cross contour on each of those would point to the center. But the other ends of the boxes wouldn't. They point to a vanishing point further away.
Got it.
That's a tough one. That's
a tough
one of those ones.
We'll save that one for your
that's-
perspective course.
That's got to be done in a perspective course.
Yeah, it's too complicated for this.
And this is all self-explanatory. It's that you've got convex cylinder and concave receiving cylinder for a hinge joint, and so that's what we're going to do next. And that's the last point.
Yep. So now you're just going to draw each phalange,
Each phalanx.
phalanx.
I gotcha.
With the you got me on that one. With the cylinders on the front and the concave plane on the back.
When you put words on it, it can drive you crazy, right? I mean,
Yeah, it's like I'm thinking about every word now. 'Cause
Yeah.
you got me on that one.
But when, thinking about words means that at least you've thought about the fact that it exists. Robert Beverly Hale says you can't draw a thing unless you know it exists, and so that's why we name these parts. And you could be a great anatomist and not know the technical names, but you wouldn't be able to keep from making up your own names. You'd call those portions of the fingers box cars, and you'd see that the body of the hand is like a cigarette pack, and so you're just going to make up your own names. It's the process of naming it something that gets your head around it. And naming it an ellipsoid joint, or a hinge joint, or a saddle joint, or a ball and socket joint, and knowing how to draw those technically means that you've got this strength and command of form that you can use in any kind of image making. I mean, this is something worth practicing over and over.
Well, here's the final drawing.
Okay.
It's done.
How did we do?
I think you did great.
You want to grade me?
Grade you on perspective?
on the drawing. If we grade me on perspective, I think I get a B. Maybe
well.
when I clean it up, I'll bring it up higher. But
Yeah, I mean the line quality I'd give you a C, but then the final one I'd give you an A.
Okay.
So, but you demonstrated an important point here is that it's really difficult to draw perspective and get your line quality perfect from your first try.
It is.
You kind of have to work it out on paper, and then once it's worked out, then you can add a layer of clean lines on top.
Yes. Now, one thing I want to mention about this, I'm going to, in defense of my C.
Yeah, but it's the C. I would probably have gotten an F just to make you feel. I mean, honestly, I would have gotten an F because I would have been struggling so much with the perspective that my lines would have just been all over the place.
I am not happy with this line quality. Let's go back and make sure that we've got the one that's the preliminary up here. I was trained as an illustrator. Actually, I wasn't trained as an illustrator. I had to figure it out as an illustrator, which meant that you delivered a finished product and nobody cared what it looked like behind the scenes, which means that I got very used to hunt and scratch line quality, which is find it, and it's a private process that you don't expect other people to see. It's being messy and private. There's nothing wrong with being messy and private as long as when you go into your finished piece that you've got control over it. But there is an advantage in your training if you want to let make it so that your finished preliminary work is nice looking, to do the stuff that Stan teaches in the gesture drawing videos, where you've got this flow of line, you're unhesitant with the line, you get the big lines, you can even chisel those things to make them thin to thick to thin, so that you don't have to apologize for what happened in the preliminary work. It's just you can speak clearly when you're at home with a friend, and you can speak clearly when you're out with others. And I think there is an advantage to it. I wish I had been trained that way, which is why when I do these demos, my biggest concern for students is that they will imitate the way I put the lines down. I hope what you got out of this was that there is logic to these forms. If you can learn to draw the box and the ball and the thing that's in between them, the cylinder, and if you master that, you've got the building blocks to draw anything, and that's what I hope you get out of this. That's the foundation of perspective, and for that matter, the foundation of illusionary anatomical drawing.
Great. Well, thank you, Marshall. That really was helpful to see the perspective of that. So thank you for doing these.
Thank you, Stan. This was a privilege to get to do this.
All right. Thanks, guys.